If you're going to use scientific notation to represent a very large or a very small number, the first thing to note is the form. The thing that always draws people's attention is that it's a number multiplied by 10 to a power, where the power is an integer. So it should be 10 to a either positive or negative value, but it should be like a whole number. This value right here, this is kind of our base that we say this is the number we want to represent. And that number should be greater than or equal to 1, but less than 10. So it should be like a single digit number, but it can have some decimals. But you shouldn't have a two-digit number here. And you shouldn't have something less than 1. It shouldn't be like 0.5, okay? So this is the standard form for this. So a number in scientific notation, an example would be something like 2.6 times 10 to the fifth. And you'll notice that 2.6 is between 1 and 10, right? And 5 is an integer. Now, what this means is essentially we're taking 2.6 and multiplying it by 10 5 times. We are moving our decimal place. Every multiplication of 10 moves a decimal and adds, I guess, another 0. So this would become 2, and then I'm going to write some zeros here. So think about our decimal was between the 2 and the 6 right here, and we'd multiplied by 10 5 times. So we'd say, well, 1 multiplication, 2, 3, 4, and 5. I would always just start listing out some zeros and then take your time carefully counting and to make sure that the decimal then goes in the right spot. And if you don't have enough zeros, well, add some more. If you have too many, put the decimal in and erase the ones that went past. If you had something like this, 3.1 times 10 to the negative fourth. Well, negative still satisfies, it's an integer, 3.1 between 1 and 10, but a negative exponent represents division. So this is saying I'm dividing by 10. Well, every time you divide by 10, you make your number smaller. You move your decimal. So again, I'm going to just put some zeros here, like that, and I'll think, okay, my decimal was right here, but it's going to move 4 times. Divide once, twice, 3 times, 4 times right here. I'm going to put that decimal, and you'll see I have too many zeros. So I can always go back and at least erase, one of them so that it looks more like a normal number, but 0.00031. Now, if you had something that was like in an incorrect form, and what I mean by that is, let's say you had something like 33.7 times 10 to the 7th. That's incorrect because that base number right here is bigger than 10. This is an incorrect writing. We'd rather move this decimal like this to be 3.37 times 10 to something. And I guess I would think about it this way. I would think this informed me I should move the decimal 7 times this way because it's positive. Well, but actually, to be correct in scientific notation, I should have the decimal here. It needs to move 1 more time. So instead of moving 7 times, it actually has to move 8. And then we should just put a giant cross through this thing because this was an incorrect way of writing our scientific notation. On the other hand, let's say you had kind of the same thing maybe. Maybe I'll change the number though. Again, that's incorrect. We don't want it to say 42.3. That's a poorer form. We want it to be 4.23 times 10 to something. Now, here, this said, you should move it 5 times. So you'd say 1, 2, like that. But now I already moved it once. I have it there. So now I don't need to move it as many times because I already moved the decimal one time. It's correctly between the 4 and the 2. So I moved it once, so it now needs to move one less time than it did before. But again, this is the correct way to write it. This is no good. We want it to be a number that's between 1 and 10. So let's think about kind of going the other way. Like, we weren't presented a number in scientific notation. Rather, we were presented the large or small number and asked to write it in scientific notation. Again, I think important to right away just say the decimal should be right here between the 5 and the 6. In this second example with the very small number, the decimal should be right here between the 3 and the 1. We always want just one number to the left of the decimal sign in our ones place. We don't want a 2-digit number. So I would look here and I'd say, well, the decimal right now is right here. I need to move it 1, 2, 3, 4, 5, 6, 7 spots. So I would say this is 5.67 times 10 to the 7th power. Here, the decimal's here. I need to move it 1, 2, 3, 4, 5 spots. I would say this is 3.14 times 10 to the negative 5th. And if you want to just think about a shorthand kind of way to think and remember, a positive number here, a positive integer, makes very large numbers because we're multiplying by 10 over and over again. A negative integer here, a negative number here, makes very small numbers because we're dividing by 10. So that kind of tells you in which direction the decimal is going. Are we making a very small number, a decimal, or are we making a very large number? And that's the way we use scientific notation to help us write really big, really small numbers. If this video helped, please like and subscribe for more math help.